again.
Yeah, great, sir. After a long time.
Yeah, it's quite long.
Yes. I heard you a couple of times in various platforms online, of course, online.
I just have seen Dr. Fatima and somebody from Department of Meteorology. Dr. Fatima, how are you?
She's muted, I think.
Yeah, either you're on. No, she is connecting.
Yeah.
There's echo. You are with two devices. Yeah.
Good evening, sir.
Good evening.
Yes, I wanted to reach you. I sent you several messages. So
Yeah, I just have seen your email. What
yeah.
was wrong is I'm outside Kathmandu and I'm going to Kathmandu. I inform about this to Saurabh as well as Sakhan. But I have to stop in between.
Okay. Is it okay with you?
Yeah, okay, no problem. We will stay a couple of hours here and we may stay overnight here. It's about 100 kilometers far from my house. And due to some procession, there is big traffic in Kathmandu city. So we will rest here. And unfortunately, we are coming back home from one conference. So unfortunately, our driver was drunk. So I have to drive some other's car.
Finally, you are here. We are glad.
Yes,
sir. Yeah. So already our session chair and co-chair is here.
Yeah, I think,
good evening.
Good evening. I think if I'm right, I should start at 5:30. That is 5:15 Nepali time.
Yeah, that's right.
Yeah, yeah.
5 minutes later.
Yeah. 5:15 or 5:45? 5:15, I think.
15, yes, 5:15.
No, you are
Nepalese
15 minutes earlier. And this is 5.
Just 5 minutes to go.
Yeah, 5 minutes. Yeah. Yes. Okay, Dr. Mondal, nice to meet you here.
Yeah, nice to meet you, sir, again after 1 year. Yeah.
Yeah, it's about 1 year. And we have a 1, 2, 3, 4, 5 presentations, right, Fatima?
Yes, sir.
Everybody are presented or not?
Two yet to join. Two persons, but first presenter is here, so second presenter and also second presenter is here.
Is already here.
And we will communicate by this time.
Okay.
So we had in the morning the inaugural session, and one session already, technical session already completed, and this is the second session.
Yeah, Dimri was here in the first.
Yeah.
Yeah, I was about to join that, but I was driving that time.
Yeah. I'd like to hand it over the session to you, Professor Deepakaria.
Yeah, we will take care. Montal and I will take care. You just can relax.
Thank you.
I will be in time. No problem. So, Dr. Mohan, I think we should start within 3 minutes. Before that, what we have to confirm is that we have 20 minutes for each presentation. Let's stop them within 15. Is that okay?
Yeah, maybe we give them a time warning at say 12 or 13 minutes after, so that they get a warning that they have 2-3 minutes.
I think, how many presentations, how many audience are there? 25 is already on board. So
Yeah,
there
25.
might be several questions.
Yeah.
Mm,
So I can see only, so the participants,
Number,
yeah, number, but they are not in the,
list.
In the list, maybe they are there. I do not know. Yeah, in the
So
list.
there
No,
are,
they are
I
not.
think, we as a panelist, we can see who
Yeah,
are the
in the list
panelists
they are
only,
there.
and attendance, there are 18 attendance. So
Yeah.
we cannot, I think the organizer has managed this Zoom platform in such a way that we cannot see at all.
Yeah.
This is confidential thing even for us.
Sir, we will allow the other participants when we give them the opportunity to they are here, but not we are showing the their videos and other audio option.
Okay.
When
You are
we
the
will
boss.
allow, if they have any question, we will allow them as panelist. Then
Okay,
we can
you are the boss for that, right?
yes, yes.
Okay, okay. I will ask you.
So when they have some questions, they will raise their hand, right?
Yes,
Okay.
they can raise their hand and we will allow them to talk.
Okay, shall I start now? It's 5:15. Okay, welcome and good evening. Salam alaikum, namaste to everybody. My name is Deepak Aryal. I am from Central Department of Hydrology and Meteorology, Tribhuvan University, Nepal. This is the oldest university in Nepal, offering MSc and PhD, as well as BSc in Meteorology. So I'm very much glad to be here as a part of, always a part of this conference since 2019. And today I'm going to share this session. And my co-chair is now Dr. Moldan from Bangladesh, Mohammad Moldan. Maybe sometime my pronunciation may not that goes well. And we will keep in track about all timings and everything. So we have altogether 5 presentators. Each will get 20 minutes. We will stop them in 15 to 16 minutes, not more than that. We will give around 12, 13 minutes. Depends on their speed and their whatever they are talking. We should take care about those things. Without making delay, I think let me introduce my co-chair. That is good. Mohammad Mondan, do you have anything to say in 1 minute?
Yeah, you have already introduced me. Good evening, everybody, and thank you, Dr. Chair. So my name is Shahjahan Mondal. You can Muhammad Shahjahan Mondal. So I'm a professor at the Institute of Water and Flood Management of BUET. BUET is Bangladesh University of Engineering and Technology. So as Chair said, it is always, happy for me and privilege for me to be part of this conference. In the last year, I also had the opportunity to co-chair with Dr. Deepal.
Yes, we were in the same group. Yes,
Yeah,
it is nice. Yeah.
So,
I already have got.
Please, sir, you can start this session.
Yeah. In the meantime, I may ask you to assist me in several times. Without making now any delay, let's start with the first presentation with Dr. Mazumdar from Indian Institute of Tropical Meteorology, Pune. He's talking about the response of soil moisture variation to the wet and dry extremes over core core region or core monsoon zone of India. Monsoons now the time is your. I
Yes,
may
sir.
allow 1 minute extra because we took that minute.
Yeah,
Yes.
I think, is it visible, sir?
Yeah, it's very nice.
Yes. Yes, sir. Okay. So thank you so much, Chair and Co-Chair, sir. It's my pleasure to be again at ICM MCS as last year, and with the same, I think, same team of Chair and Co-Chair. Thank you so much, sir. Namaskar ji. Today my topic is the response of soil moisture variations to the wet and dry extremes over core monsoon zone of India. I will be mostly focusing core monsoon zone of India and with the observations. They are my co-presenters, Mr. Mangesh Goswami, Naresh Ganeshi, our research student, Bhupendra Bahadur Singh. He is our colleague, young colleague, Madhusudan Ingle, he is research associate, and Dr. Krishnan, R. Krishnan, who is our mentor. So this is, we are working with the IITM at Center for Climate Change Research, CCCR. And I'll just briefly, last time also I had introduced this book. This is the open access book. There are 12 chapters in that, and it is easily downloadable. So the link is given on the top. And just let me begin all the reports. This climate change report, IPCC climate change report, the main thing to highlight, yes, temperature is rising, but where the important thing is the land. The rate of change of temperature on the land surface, that is much more than the global, that is with the land and ocean. Particularly, I will come back to these things. So the land, the climate change, the land plays an important role in climate change. This is again from our book, and we can very clearly see the temperature rise. Of course, this is RCP 4.5. I will not go into much detail. This is mid-term forecast, and then century and long-term forecast. But the thing is, you can see this is over the Himalayan region, highly elevated region. This is over the plains, and this is over the ocean. And you can see very clearly over the land, particularly over the highly elevated regions, this is the temperature rise is higher as compared to oceans or surface also, land surface also. But in short, land surface plays crucial role in climate change. This is what I wanted to bring. Again, this last time also I had presented this, but this 2015 monsoon, this we published in Climate Dynamics, this 2015 monsoon, again, it covers a larger area. Actually, it was not restricted to Indian only, but this deficiency was so distinct that even it extended over the Indo-Malaya region. And Indo-Malaya region, what I mean to say is, just let me show this. So this Indo-Malaya region is one among the 8 eco zones that covers Earth's land surface. So entire region was under the drought or this dry conditions, encompassing South and Southeast Asia, extending into Indonesian region and southern equatorial region also. So again, to bring this, the land's response to weather and climate could be severe. The thing is, I will quickly go to this Professor Manabe, who recently got Nobel Prize of Physics. So he had brought out this in 70s, 60s, and 70s. It is very remarkable. Using very simple model, what he showed is soil moisture is an important component. Of course, I mean land. I will just stick to this. Is an important component of the hydrological cycle. And how? So the main thing is through interactions of or exchanges of surface fluxes, latent heat flux, surface heat flux, ground heat flux, and so on and so forth. And another, I mean, unique this characteristics of the soil moisture is the memory time scale. It has a memory. Soil moisture has a memory, and I mean beyond its spatial heterogeneity. That is another characteristic. But this is what is using this simple climate model, the climate models. Professor Manabe and his co-authors, as his associates, they estimated soil moisture decay time scale over the globe. And what they brought out is the distinction between the extratropical region and tropics. Extratropical region, it is more than 2 to 3 months, while it is below 2 months over the tropical regions. And that is a really remarkable thing, how it plays an important role in climate change. I'll come to this again point. Very clearly, I mean, very simple with the experiment with climate, very bucket model experiment, what they showed is interactive and non-interactive, where the interactive case, the soil moisture, they varied. And in non-interactive case, the soil moisture was under the control condition, constant condition. And very clearly you can see this is the zonal mean variance of temperature. I mean, this is the very clearly you can see this distinction. What in the interactive case, what you see in the interactive case, it is sensitive to the soil moisture. And of course, in the northern and southern hemisphere, you can see obviously, I mean, southern hemisphere land mass is less, northern hemisphere land mass is more, but particularly in the tropics and extratropical region, this sensitivity is very clearly seen in terms of the zonal mean temperature variance. And this, based on these things, of course, I mean, our student, this Naresh Ganeshi, this paper we have submitted in Journal of Hydrology recently. But what he did is using very high sophisticated MRI model, this soil moisture memory he estimated over the Indian region, particularly over the Indian region. And here you can see very clearly the soil moisture memory varies from 10 days to 2 months, if you see, and particularly over the central India, you can see very clearly. This is very crucial. And the thing is this, continuing from Mr. Naresh Ganeshi, our PhD student, from his previous work, he identified a region where this impact of soil moisture is very intense, or it is worth investigating it. So he identified the region where this soil moisture temperature coupling is very strong, and that is the north central Indian region. How he computed and all, the Darmeyer 2011 he followed, and this was he did it with the using GLDS data and other observations over the. I will come to those things, but main thing here what he has done is using this high resolution climate model. So this north central India, you can see this identification of the strong coupled soil moisture temperature coupling region, and using the sensitivity experiment, one experiment where the soil moisture is reduced by 20% and another experiment where the soil moisture is increased by 20%, you can very clearly see when the these extreme temperature events were analyzed. You can see very clearly in the case of dry soil moisture simulation condition sensitivity experiment, this PDF, you can see very clearly enhanced extreme conditions, extreme temperature conditions over this north central India, the region of strong coupled region. So again, the thing is that this soil moisture, again, this soil moisture has an important role in climate extremes, and particularly this importance, I want to bring out this importance of this field scale soil moisture variation. Field scale, what I mean is area average, and taking into account this heterogeneity also. So evaluation of this extreme and various hydrometeorological applications. So this is very important, actually, importance of this field scale soil moisture variation, and how to estimate, how to compute it, how to get it, observe it, that is another challenge. And this is very clearly seen in terms of this recent report, as I said, this IPCC report, special report, this special report on climate change and land 2019, this reference is given. Of course, there are some publications also. So the role of this soil moisture in evaluation of extreme variation of soil moisture in extreme conditions, and particularly this frequent floods and droughts, this soil erosion, soil desertification. So these things are very important. So what we need is, the important thing is the soil moisture observation, how we do this thing. Of course, I will not get into detail because the time is very small. Main thing is, our objective here is to highlight the field scale soil moisture monitoring. What is the use of, what is the benefit of this field scale? What I mean is, field scale is area average over the 0.5 by 0.5 kilometer resolution. Of course, taking into account this heterogeneity also. And there are advantages, disadvantages. I will not get into more detail in this, but this is a very high frequency and very latest cutting edge technology what we are doing here. And using this soil moisture, how we can get into this extreme and the hydrological hydrometeorological events or these various phenomena. So this is actually first and foremost is radar. They carried out in 2008, 2012. Continuously they have been doing this using the gravimetric method, and for that they have designed complete experiment. It will be very difficult, but total in short I can say there total 108 in situ observations we have to take, and then using these observations average weighted, you can see these profiles also, and area average weighted for layer by layer, you can compute the soil moisture. So this is the first time they have brought out how the auger has to be made, and these are different things. I mean, again, with the time, for the want of time, I will cut it very short. So the thing is, this is the cosmic ray soil moisture sensor. This is the new technique. Very short, I can say, briefly I can say, this is the technique where this neutron counts, cosmic ray, when it comes to the ground level, it loses its energy from 1 gigawatt volt to 1 volt, 1 electron volt. And how? Because of this, it depends at the surface. It depends on the wetness of the surface, soil moisture, and the atmosphere also. I mean, moisture it reduces its energy, but at the surface, the soil moisture reduces. Again, there are a lot of neutron theory in this hydrogen atom, how it decomposes and how it reduces its energy. I cannot get into detail, but this neutron, whatever neutrons, low energy neutrons are emitted from the surface, either wet or dry. So depending on this, it is captured in this probe, and those counting those neutron counts, we can calibrate the soil moisture. First, it was investigated by Vector Hess. Then it was considered to be this noise. Actually, the moisture in the atmosphere as well as the this Earth surface, it was considered to be the noise. But in 1966, this Hedrick and Age, they come out with the thing, no, it is not noise, it is a signal, and they produce this signal in terms of soil moisture, particularly percentage of volumetric water content. Then the thing is, then it, of course, it took long time. I am just jumping from here. So Zreda et al. 2008, they made this non-invasive, main thing is non-invasive probe.
Can you
and
sum
then,
up? Can you sum
yeah,
up?
yeah.
And,
And
among
then,
the audience, if you have a questions, you can start to write down in the chat box.
yeah. So this is one. I mean, this is our site, and I will go to this calibration. I will just leave it. This is how the characteristics are, and then of course we are using that. We have published the paper, and this is the main thing: high frequency soil moisture variation. You can very clearly see here the how this seasonal cycle, annual cycles are factored, and not only this, but it also gives the depth also. And particularly the thing is, of course, this meteorological rainfall also you can see very clearly. Important thing is this 2019 extreme. What we want to bring out is 2019 extreme, when that both the things, dry and wet conditions were extreme. You can see the evaporation, this Buoyancy Ratio, which indicates the heat exchange from the surface. So pre-monsoon season, it was highest during 2019, and the same was 2015 also. I will come to that, and you can see very clearly this how these rain spells, they influence these rain spells during 2019. They influenced the soil moisture and created after the half of the season. You can see very clearly after the half of the season. I mean, in the beginning it was less, but later in the later part, it lot of these rain spells, they influence this. Of course, we have done this thing also. You can very clearly see that how these rain spells, these are the rain, this is wavelet for rain spell, and this is for soil moisture. Very clearly, 10 to 20 days and 30 to 60 days, these modes, how they reflect in the energy transformation in soil moisture. And particularly the soil moisture memory, particularly you can see very clearly different years. You can see where this 2019 and 20, both the soil moisture memory, what we computed was lasting more than 60 days for wet conditions. You can see very clearly, while the 2015, you can see, of course, this is over the Cosmos region and Pune site, but that is also part of this core monsoon zone. But you can see very clearly here the soil moisture memory was lasting barely about a week, about a month or so. But in case of 19 and 20, it was exceeding 60 days or 2 months, say. And this is what is the actually difference between 2015. You can see the difference between 2015 and 19 over the core monsoon zone, entirely core monsoon zone. And Pune is the region of Pune belongs to this thing. You can very clearly see the opposite phases, particularly during this monsoon season. And monsoon has the profound influence on these extremes. I mean, 2015 as well as 19. You can see the 19, always this soil moisture kept increasing, while in the 2015 soil moisture kept decreasing. It diminished, and you can see where the same way here the rainfall also It has very strong spells you can see during 2019 as compared to, of course, using this. These are not the affordable Cosmos techniques, but what we are doing is we are doing this subsurface profiling using this sensor network and low cost sensor network we are developing with the help of these colleges, interns, students, dedicated faculty, students, stakeholders and things. And you can see very clearly this 1 meter depth soil moisture profile using this very low cost sensor. How we could again, time is not there, so I'm just cutting it short. And just to summarize this, we have done this quantitative evaluation using this field scale and high frequency data. This is the first time in here we are able to estimate this quantitative evaluation of the soil moisture variation at different scale and compared to other whatever these products are available. And the important thing is the memory time scale, the estimation of memory time scale. Over the Indian region, memory time scale is almost, more than a month, you can say roughly. But 2019 and 15, you can see the distinction between this memory time scale. 2019 exceeded more than 2 months, while it was barely 1 month during 2015 drought year. And the main thing is our attempt is to make this soil moisture profiles, actually field moisture, soil moisture profile to up to 1 meter depth. This is what we have called up to only surface, but this is up to 1 meter depth. And how we are doing that, how this observational network, wireless network, we are establishing through capacity building using these low cost sensors and the dedicated faculties, students, stakeholders and others, NGOs and other things. So that is what is my presentation. Thank you so much. I'm happy to take.
Thank you, Majumdar. Okay, among the audience, if there is one question, I think we have a time for one question.
Sir, if you allow me, I can ask one
Yes,
question.
please. Sure.
Yeah, we know, soil moisture is dependent on also, rainfall and soil texture, even
Yes,
including organic content.
Yes, sir.
But I did not get a very clear picture, the role of rain and also the soil texture.
Yeah, I had made this soil texture. You can see very clearly this all this information when we calibrate this, it gets into this coding. There is no time to tell all these things detail. But when we do this, particularly using the gravimetric method, 108 observations, all this information we have to get. All these soil characteristics, it goes into this this coding. And important thing is, more than that is calibration also. I could not show you how these corrections are done with respect to the surface condition, biomass below the ground, above the ground. There are various factors actually how this calibration is done. And what you say is, after the rainfall, you can see very clearly that is what is how this energy transform from this 10 to 20 day, 30 to 60 day these spells, rain spells, these oscillations to this soil moisture memory. If you have these spells, short duration, medium, moderate duration, or long duration spells, that is 2019, that was considerably high. And how intense, that it depends on its intensity. That intensity only transforms that energy into soil moisture memories. So 30 to 60 day, you can see that in the wavelet as well as it's a memory.
Okay, with this, I think we should move to the next. Next is future drought characteristics analysis of northwestern region of Bangladesh using Cordex data. Sabista Ildiz from Department of Meteorology, University of Dhaka, please. And if there are some questions from the audience, please start to write in the chat box. Sabista.
Yes, sir, I'm hearing you. I think, yes, I think I should start sharing my screen.
Yes.
Good evening, everyone. This is Shabista Ellis. I am from Department of Meteorology, University of Dhaka. Today, I am here to present my undergraduate research work, which was future drought characteristic analysis of northwestern region of Bangladesh using Cordex data. Before going to the main session, I think I should acknowledge both of my supervisor, MD Abdul Mannan and MD Marufur Rahman, because without their guidance and cooperation, it won't be possible for me to carry out this work in the COVID situation in lockdown, totally at home. I'm also grateful and thankful to my current department for organizing such a conference and providing me opportunity to share my research work. So this is a little bit of background that why I have chosen drought among all other hazards, and how is it significant. So we all know that drought is basically a period of dry weather when rainfall amount just goes below down the standard than it's supposed to be. And as for Bangladesh, we basically define a period as a drought if the annual average rainfall is below, if there is 25 to 50% deficiency in the rainfall. This definition may vary with geographic extent and duration. For example, in Bali, without 6 days of rain, they consider the period as a drought. But for our country, we usually consider like 25 to 50% deviation from rainfall as a drought period. And years of meteorological drought may also reduce the soil moisture content and also may lower the groundwater level, which may trigger then hydrological and agricultural drought. And the history of drought is not new for Bangladesh, and there is a huge chronology of it. And the most prominent ones, most 9 prominent ones since 1971 were observed. And for 1994-95 event, at that year, the wheat and rice production loss was huge. Amount were lost or destructed because of this event. Even World Bank has estimated that because of water crisis and climate-induced droughts, some East Asian regions will face a decline of GDP by 6% by 2050. So this is not insignificant, and along with the hard hit or fast onset events like flood and cyclone, this also has some significance. And we all know that climate is changing, and there are many evidence, scientific proven evidence behind this. According to IPCC fifth assessment report, they have predicted that the temperature will rise by around 1.5 degrees Celsius by the end of the 21st century. All of these results were generated from the simulation of global climate models. So what I have tried in this study is take an attempt to use the global climate model outputs to generate some outputs to see how the future drought characteristics will be for the northeastern region of Bangladesh. And for that purpose, I have used the standard.
Your slides are not moving.
So I'm still explaining it.
Okay.
I haven't changed it yet. So the standard precipitation and evapotranspiration index, this is I'm going to use. For majority of the study of the droughts in our country, we use the standard deviation of rainfall and ignore the temperature for calculating the deviation. But when we are going to calculate a net water balance, we also have to consider the temperature, because not all the precipitation is received received by the ground. There is obviously some evaporation and evapotranspiration. So when I'm going to calculate the water balance, I think we should consider this. So that's why I have considered this index here. These were the research questions under which my research was carried out. First, I have selected which models will best represent the Indian summer monsoon, because I have to take the data of rainfall and temperature to further calculate the index. The second thing was to I have to select an index which will help me to develop the future drought scenarios, and using that index, how will be the future drought characteristics of this region, where the third objective or question. So this is the northwestern region of Bangladesh, which is my study area. I have used this region as my study area because comparing to other regions of Bangladesh, the temperature and rainfall variability is a bit higher in this region. In cases, the summer temperature may rise as high as 45 degrees Celsius, and in cases, it may go as low as 5 degrees Celsius in winter seasons. And the rainfall amount may vary greatly from the west northwest region from the northeast region, and the gradient is around 9 millimeter per kilometer from northwest to the northeast. And also the soil moisture soil is very sandy in nature. That's why the retention capacity of water is also lower for this region. This is the workflow of my work, flow of the work. So first I have carried out the literature review to identify the models and then collected the data to calculate the index to generate the characteristics of the rod. So here goes the result and discussion sections. I have shown here the graphs, I mean, basically the trends of temperature and the rainfall. The left-hand side graphs are showing the temperature trends and the right-hand side two graphs are showing the rainfall trends. But the temperature trend, it is statistically significant with a 95% confidence interval. But for the rainfall, it is not significant because the probability of error was higher comparing to the confidence level. So both of the model has estimated that by the end of the century, the annual average temperature may rise by 1 to 2 degrees Celsius. And for the rainfall amount under RCP scenario 4.5 between 2060 to 2099, it may be around 2000 millimeter. And under the worst case scenario for RCP 8.5, the rainfall amount may vary between 1892 to 2400 millimeter. So this is my index, what I have used to calculate the further drought characteristics. To calculate this index, I have first carry out a work on potential evapotranspiration calculation. To do that, I have take the rainfall data and then have take the evaporation data to find the potential amount of water that has been evaporated, and also the latitude information, the geographic information were incorporated in this to calculate this index. So I haven't shown here the equation to reduce the complexity, but there are sets of equation to calculate these. And then what I have shown here is the category of droughts. So if the calculated SPI value is between -5 to -1, then it will be defined as a mild drought. Between -1.5 to 1, it is a moderate, and less than -1.5, it will be considered as a severe drought. Now let's come to the right hand side where I have shown the graphs of the SPI index. I have calculated it for 3 time scale, 3-month, 6-month, and 12-month index for 2 models. So if we look at the left hand side, we are seeing that the SPI index for the MPIESM LR model under the RCP scenario 4.5, the negative magnitude of the SPI is going higher from the midway to the end of the century, but which is a bit gradual for the NORIESM model. Same goes for the 6-month time scale and 12-month time scale. So let's come to the characteristics. So first come the drought duration. I try to draw a relation between the duration of the drought with its rate, obviously per year. I have taken 3-month, 6-month, and 12-month index. 2 of the boxes are present in this slide. The first box is for the scenario RCP 4.5 and the lower one is for RCP 8.5. Now let's come to the first graph of the first box. So I have shown here that 3 time intervals. The orange time interval is for 2006 to 2019. The yellowish one is for 2020, and the greenish one is towards the end of the century, which is basically 2060 to 2099. What is shown here that the short duration drought is slowly increasing in its rate, whether it is a 3-month, whether it is in the initiation of the century or towards the end of the century, which is same for the medium-term drought and long-term drought. Now, what is the short-term drought? For my purpose of study, I have considered that drought with a duration less than 3 months or equal to 3 months as a short duration drought. And if it's between 6 months, then I have considered it as a medium term. And if it's up to 12 months, then I have considered it as a long-term drought. But I have seen from here that all three types of droughts are showing a rising rate towards the end of the century. Though the magnitude is a bit lower for 4.5, it is much more higher for RCP 8.5. Now let's come to the point of severity. So for my purpose, the severity is basically the per month magnitude of the SPI of the drought. So what I have to do is that I have take the algebraic sum of the SPI index for the consecutive months or drought spell, then divided it by its duration, then I get the per month severity. And I have drawn here a relation between the severity with its duration. Short, medium, and long-term droughts all are showing that their severity is increasing, means their SPI index value is going below minus 1.5 towards the end of the century. There is an exception. If you look at the circle of the first box in the second graph, then we can see that for long-term drought, the severity is going down. After getting the output, I was a bit surprised that though all the droughts are showing that their severity is going increasing towards the end, then why it is showing that the severity is decreasing? Then when I go back and studied all the data, then I have seen that it is because the model I have used is overestimating the rainfall amount against the observed data. That's why this model is overestimating the rainfall amount and therefore underestimating the severity. Now let's come to the point of frequency. I have drawn the relation between the severity and frequency here. This is a very simplistic relation. It is showing that the severity of the mild drought is decreasing, the severity of moderate drought is increasing, and same goes for the severe drought. But difference between the two models is that though the frequency is increasing in the middle of the century for MPISM LR, it is towards the end of the century for NORISM1. Now, if I sum up all the outputs of my study, I can see that for both RCP scenarios, short, medium, increasing toward the end of the century. For the severity, short, medium, and long-term droughts shows an upward trend toward the end of the century. For RCP 8.5, there is an exception for RCP 4.5. And as for the frequency, it is also showing an increasing trend towards the end of the century, which is basically 10% between 2060 to 2099 for 3 and 6 month index. For RCP 8.5, the frequency of the severe droughts may exceed about 8 to 6% towards the end of the century for all time scales. But there are some obviously drawbacks of this work. I have calculated univariate relation between these characteristics. So I have a plan to go further with this work and do a probabilistic distribution of this characteristic, and also like considering the uncertainties. So that was my work. So if you do have any question, please go.
Okay.
Thank you, everyone.
Thank you, Abhishta. Wow, nice, thank you. If there is any questions from the audience. No questions? Can you stop sharing slides? Abhishta, can you stop? Yeah.
So if there is no question, I may ask one question.
Please, yeah.
Allow.
Yeah, we
Yes,
have enough time now.
Yeah, maybe I can start the question with her observation that she can go for bivariate distribution. So if she can shed some lights on that, what does she mean by bivariate distribution in the context of drought? Is it evaporation and rain, or something?
Sir, actually, when I'm showing the graphs, I am showing in a way that I'm showing the relation like say I'm showing the frequency and I'm showing the severity, but I'm not considering the duration. So while I'm going to consider the duration, severity, and frequency, all three in a probabilistic way, that would be a multivariate way to find the frequency. But in this study, I have shown it in a univariate way, two a relation, like I'm considering the duration and frequency one time, then I'm considering the frequency and severity, then I'm considering only the severity and the frequency in this way. But when I'm going to compile all three together, then along with the uncertainty, it will give a more wholesome situation, how the future situation will be for the drought characteristics.
Okay, so by variable, you mean characteristics of drought.
Yes, sir. Yes, sir.
But usually when we say variable, it means different things. For example, one variable is evaporation, another variable is temperature, things like that. But in your case, you are referring to characteristics of drought. Yeah, okay, now it is clear.
Yes.
Maybe I can ask you another question. I mean, when you divided the time span, you divided in three span, right? 2006 to 2019. So it was about 15 years. Then 2020 to 2059. So it was about 40 years. Can you tell me why you picked these different types of?
Yes, sir. I can tell. Yes, sir. Yes, sir. I can tell it. It's because the model data is available between 2016 to 19 for all data. That's why I have taken only 15 years to bias correct the data. If it was available for way back more 20 years, then I can also use them. That's the reason.
Okay. So I got your point. It was something like to calibrate or validate your model. Yeah.
Yes, sir.
Understood.
Thank you. Yeah, I think, thank you, Savista. You have done a lot of analysis and used a lot of data. So I may not have any questions. If I have, I may have to. There are some colleagues who are using during drought in Nepal also. These people might be useful for you and for your further. What you are doing, you are a graduate student or you just passed?
Sir, I have recently graduated and now I'm an MSc student.
Okay. So I will connect somebody to do a little more about these things. We have some experts in Tribhuvan University. So that may be helpful for your further research. So according to organizer, yeah, I will do that. According to organizer, Vaskar Sharma from Bhutan has not joined yet. Vaskar is here. And again, Mithun is not joining for right now. Maybe he will come a little later. I will proceed to the Shaurabh. He is talking about the WRF hydrometeorological or prediction of floods in, using the WRF, how can we predict the floods? About these things, Saurabh is going to tell. Saurabh, can you proceed your presentation?
Yes, sir. Thank you, sir, for allowing me this opportunity. Let me just share my screen. So just a few seconds for the slides to show up.
Okay.
Sir, I think you can see my presentations. Is that right, sir?
Yeah, it's okay.
Okay, and also I'm audible enough.
Yeah, it's nice.
Okay, thank you, sir. So basically, the title of my presentation is Application of WRF Hydro in Prediction of Floods in Bangladesh. So let me just go through about what we have done or what I am going to show here. is that actually what we have done so far at Department of Meteorology, University of Dhaka, regarding to the prediction of floods, as well as any sort of hydrometeorological events. We have actually begun or started with floods, and we plan on to go with other hydrometeorological events. And so just to reiterate the fact is that, so this is actually well known to most of us, and the fact is that due to the geographical locations or settings of Bangladesh, basically the country is prone to flood events, and mainly the four types of floods we see here in Bangladesh. And as you can see, there are the areas, the flood prone areas are shown. Flood prone areas are shown in along with their legends. And so that got us thinking is that what we do as meteorologists, we predict the weather with a subsequent lead time in sort of advanced techniques. So that what we started to conceptualize or initialize is that if we could incorporate the weather prediction towards the hydrometeorological event predictions as well. So WRF Hydro has been subtle, I mean, I would say, a scheme for us as meteorologists to predict or to assess the hydrometeorological events. So it's basically, as you can see, it's a community-based supported coupling architecture, and has multi-physics and multi-scale options. And what it does, it actually takes some fundamental surface flow equations that are expressed in terms of Saint-Venant equations, as well as Darcy-Richards equations that deals with subsurface flow equations. So if we move on, what we actually can operate with WRF Hydro is basically in two modes. One is the coupling mode, and the other is uncoupled mode. So the coupled mode is actually good if you want to do any sort of real-time prediction of events. But if you want to analyze the events or study it more, you have to go for the uncoupled mode. And there is, you can see there is option for data assimilation within the model. So just we have, just as I have reiterated in the beginning of my presentation, is that what we have done so far at the department. So as you can see, there is actually one recently published article based on our works, and these are actually two presentations that we did in last couple of years. One at AOGS recently that was held, and the other one was back in January. I says 2020. Many of you were here for that conference. And we, at the beginning of our work, we didn't employ a very sophisticated methodology. Our methodology actually revolved around these three steps. Is about studying the pre-events, studying the precursors of the event like rainfall, and then to study the post-events like what happened after the rainfall, and just assess and evaluate the performance of the models and derive our results. And that's through some statistical models like statistical evaluations, I'm sorry to say. Those are basically NSE and RSR, as well as some bias scores. So the first one was simulation of flash floods with WRF Hydro. So we employed, as you can see, I've shown before, that the first step is always about studying the rain or the pre-events. So those were done through the WRF AirW scheme, and the parameterizations are given within. Mind you, this has been used for the publication that I showed earlier in one of my slides. And next up was assessing the flood event, and that's through WRF Hydro, and the configuration is given here within. So as you can see, we went for 3 events. The first one was at the 2016 flash flood event. So we went for the WRF one and also assessed with the GPM as well as station data from BWDB. And similarly, we did that for our 2 events in 2017. One was at the beginning of the month and the other was just around third and fourth week of the month. So similarly, we employed WRF outputs and assessed it against GPM data as well as BWDB station data. And finally, this was the surface runoff event scenarios for the 3 events. So based on our assessment, what we actually achieved here is the rainfall against the water level and against the discharge scenarios. And all these are simulated scenarios. And then we actually tried to create the hydrograph for all the 3 events and finally found that the lag time is 6 hours, 27 hours, and 3 hours respectively for the 3 events. And again, all these scores that I showed you were evaluated with NSE scores as well as RSR scores. And those evaluations were done against GPM as well as the BWDB stations data. But the important thing to note in this slide is the portions of rainfall that actually contributes to the flood event in Bangladesh. So as you can see, these 3 events, they actually have 3 types of lag times. And if you can see the distribution of rainfall, there is a clear around a scenario that we can generate from here. See, if the rainfall around the Bangladesh portion is considerably not higher, we tend to get a flash flood event with a bigger lag time. If it is considerably higher, we get a flash flood with a very short lag time. So this was done, mind you, for 3 events. We plan on to do it or replicate this method and process for all like other 10 or 15 events or maybe 20 events if possible, to check if we are actually correct about our findings or assumptions or hypotheses. So next up was the one we did for the coastal flood simulations using the WRF hydro model. And this was actually done for 1 event only, is the recently the cyclone Amphan, not recently actually, it was in last year. Cyclone Amphan hit Bangladesh and subsequent coastal floods were occurred in some parts of the coastal districts of Bangladesh. So first up, what we wanted to achieve is if we could just check if our microphysics scheme works well with the cumulus physics scheme. And that's why it's done, because to see if the ARW portion of our simulation can better portray the rainfall event or the pre-events of any flood events. So as you can see, 8 experiments were segregated, and based on our experiments, we actually derived this configuration. And finally, what we wanted to do is do the similar thing and get the scores, the RMSE and p-bias scores. And we found that this one actually did better, experiment number 5. If we go back, experiment number 5 was actually microphysics scheme, Morrison 2 moment, and cumulus physics, Canefish cumulus potential. So based on this, we checked against the BWDB station data and found the results to be more or less validating against the simulated results. So again, we did this for water level as well. And this was our performance scores for the model simulated results, NSE and RSR. So finally, what we wanted to see if the p-bias or percentage or the error percentage within the simulations. And we saw that if we increase the lead time, the errors actually start to increase as well. So we come to a conclusion, just to reiterate again, this conclusion is actually valid for both the experiments that we did. That means simulations of WRF hydro for flash floods and also for coastal floods. Now, actually, what we did here, we actually did not produce any prediction. Rather, we actually did hindcast. Now, therefore, we actually would like to say, if we want to try the for operational basis, if we want to try the WRF hydro model, we would like to have, like, say, for example, the GFS data. But again, GFS data is a global data set, so it must not have every local attributes within the data set. So data assimilation is a must for us if we want to get a better results. And finally, if we want to do further assessment, we need to check the physics parameterization schemes as well to check if the physics is contemplating against our geomorphological, geological, and bathymetrical settings as well. That's all I had to about my presentations. Thank you for listening me, and thank you all again.
Thank you, Saurabh. Thank you. You have done well. And I may have some questions. Before that, I would like to go to the audience and our co-chair if they have any questions. There's no questions in the chat box. I think everybody understand you, or they don't understand anything from you.
Thank you, sir. Sir, just one thing, maybe Mr. Bhaskar Sharma has joined.
Yeah. I have his information. I would like to invite him after your everything finished. So, Saurabh, I have a quick question. Are you using WRF, and are you using any hydrological model?
Yes, sir.
What kind
Basically,
of,
yes, sir.
what kind of hydrological model?
Okay, sir. So what the WRF hydro architecture is such that it actually incorporates the hydrological model, like the loss methods, and also like subsurface flow.
That
and
is inside
also,
the WRF. That is inside.
yes, sir.
the
The architecture is built like that.
Yeah.
That if you actually go for the AirW, you can actually can generate the hydrological outputs as well.
No separate hydrological model, like somebody are using Climada, somebody using Hague HMS, and somebody are using SWAT. You are not doing that.
So just like I've showed in my presentation, there are two options. You can go for the coupled one, and you can go for the non-coupled one as well. So if you go for the coupled one, you can generate everything at a go. But if you want to generate the output separately, you can go for the non-coupled one. In that case, it's the working flow is actually same as working with any other models that you mentioned, like a HMS or even Mike.
Saurabh, are you agree with me that many people are very lazy now due to these computer models? So
that's
because I spent so many times in observation and measuring data. And did you do some insight measurement?
Yes, sir. I mean, I checked the model simulations against the BWDB observations. BWDB actually stands for Bangladesh Water Development Board. They have rain gauge as well as they have discharge outputs also. And also they measure water level at the daily basis, once in morning and other in the afternoon time. So they have huge coverage of data. So what I did, when I got the results from simulations, I verified whether my models are actually doing it, portraying the result perfectly or not. Because in some instances, we actually found that the model was overestimating a lot. And then we went back to check if the physics and other options were incorporating the forcings really well. Then when we tweaked those things, we found that the results were getting better and better, but it's still not the best. We have to do a lot of works, just like I've mentioned. And most probably the data assimilation part is required in this part, actually.
Next, Mondel, please, you have something?
Yeah, I can ask. It was not very clear to me actually where was the calibration and validation done. So one thing. Another thing is that given this is a coastal phenomena, whether
Yes.
hydrological model at all will be appropriate for this type of simulation. That is a big question.
Yes, sir. So the coastal one is our actually the second experiment, and it's we haven't actually finished working on it. The flash flood one we have actually assessed and reassessed, and finally we got results that actually satisfied our queries. And as you could see, is that this one actually got published very recently. And the coastal one is still in progress, and we haven't actually, we have some queries left within ourselves as well. But the initial results, they show some promising results, but there are some issues that needs to be addressed. And as you mentioned about the other one about validation and calibration is that we actually, what we did, just like I've mentioned before, first we did, what we did is we simulated the scenarios with the WR5 model, and we received the water level as well as discharge data. And similarly, we obtained data from BWDB, the water level and discharge. And side by side, we calculated NSE, RSR, and as well as some bias scores, basically person bias. So those scores, if they satisfy or they show good results, then we go for further analysis. If they don't show good results, we further tweak the physics schemes and try to simulate again.
I think, thank you, Saurabh. I think we
Yes, sir.
would like to stop your talk, and if possible, we'd like to invite Bhaskar. Bhaskar, can you join?
Thank you,
with
sir.
us? Yeah, welcome. We just have a message that Bhaskar can log in or log out. It's very difficult to join. So at this time, we should stop this session with only 3 presentations from Saurabh.
Sir, I think, sir, may I just add, Mr. Bhaskar Sharma is changed as a panelist. He can speak if he unmutes himself, he can speak for and as well as present.
Okay, Bhaskar, please. Okay, he said that it's not
Very
possible
unstable.
for me to present. Very unstable network. Okay. Okay, I think with this we should conclude. Mortal, you have anything? Any concluding remarks?
Thank you, sir. We have seen 3 presentations in this session. I would say that there was a combination between senior presenters as well as junior presenters. And all the presentations are, I would say, reasonably good, particularly the senior presenter. His presentation particularly attracted my attention because there are a lot of original work in the sense that soil moisture, instrumentation, and comparison. And in the event of, in the era of this climate change and hydrologic and climatic uncertainty, I think this work is very much useful. Similarly, the 2 relatively younger presentations from University of Dhaka were also very good. And as Saurabh mentioned, one of their works has already got published in a journal. But regarding these 2 later presentations, I think there are areas of improvement, and they have acknowledged that. But I would like to congratulate all the presenters, and I hope the younger presenters will keep their work and publish their work. I would also like to thank Chair Sir, the organizer, for inviting me to join this session as a co-chair like the last year. So particularly Professor Tohida and her colleagues. So it has been indeed a pleasure and honor for me to join this session. And also it was, very nice to join with you in this session. So this is the things that I can say from my side. Thank you, sir.
We are always together, but one day I think the COVID should gone so soon. That's in that case we can have a physical meeting so many times between Kathmandu and Dhaka. So thank you once again, the organizer, for providing me this opportunity to chair this session. This is really a wonderful session. So one of the major things I did mistake is that I should read the abstract and I should allow the timing according to this abstract and the content inside. I'm very sorry, Milind, Muzumdar, I should allow you some more time if I know two presenters are not going to present. So it was really, really very interesting, and you learned a lot of things, much better than me and some other colleagues inside this this workshop, I think. And I would like to congratulate all presenters. They all are very nice. Sabista, I think you have to work a little more hard as a professor, as a senior. I'd like to suggest you to consult with me for further collaboration with us. And now this is the time. COVID gave us some excellent platform to work together without meeting and by webinars and some other things like virtual gathering and some other things. Next is we all have a similar kind of situations, meteorological disasters like in Nepal as well as in Bangladesh and some part of India. We have a monsoon prone area. So we have a lot of thunderstorm, cloudbursts, avalanches, snowstorm, a few other things. So we should work together, and we have some kind of a group like extreme event group, and now we have a SAMA also to work for together. So in future we can do a lot of research together. And last year we got 2 students from the University of Dhaka. They did well, and they already published their at least one articles in our journal. I'd like to invite some other people who are interested to publish there. We have a separate journal for hydrology and meteorology. And special thanks goes to Professor Tuida Rashid. I have seen her name as a Dean of Faculty of Environmental Science, Earth and Environmental Science. And I want to see her maybe more than that. She's also taking care of meteorology as well as Dean. Maybe next future, we hope to see her in better position again and again. So thank you very much. With this, I would like to conclude this session, and thank you, my dear co-chair. And hope to meet you again. Thank you very much.
I hope too, sir. Thank you.
Dr. Fatima, is now up to you. Saurabh, any more announcement?
Thank you, sir. So,
sorry for the technical glitches, sir. I would ask all the participants to turn on their video so we could actually take a virtual photo if it is possible.
Yeah, it's nice.
The participants, if you could turn on their video. From the panelists, actually, the participants are within the panelists.
I think I'm okay, right?
I think Dr. Milind, if you are there, if you could turn on your video, and so as Sabista, who's actually my student.
Oh, Sabista. How many students are there?
Unfortunately, my webcam is broken. That's why I
Okay.
also not able to open it during the presentation.
Okay,
This is also nice.
In that case, if Dr. Milind is there, sir, if you could turn on your video. Okay, sir, I think we can conclude here, and thank you again to Dr. Deepak Kariyal sir as well as Dr. Shahjahan Mondal sir to be with us again. And we are very happy is that you in such short notice you actually agreed to be with us here today. I think Dr. Deepak sir actually is in some sort of difficulty today, but still you managed to join us. We are really in debt from the conference secretariat to you for presenting for be with us today, and so is Dr. Mondal sir. Heartiest gratitude to you as well. So again, and also I'd like to thank the participants, Dr. Milind Majumdar sir and also Savista. Unfortunately, we could not have Dr. Bhaskar Sharma as well as Mr. Mithun Datta with us, probably due to some technical difficulties. But thanks to all the participants and also all who have joined us within the session. And thank you to both Deepak sir and Shahjahan sir again. And please join us in our next technical session, which actually starts roughly about 1 hour from now. So see you there in the next technical session. Thank you again.
Thank you.
Bye,
Thank you,
day.
Saurabh. Thank you, Dr. Fatima.